Hey, Jeff, we're live again.
Hey.
We're both tired. It's been a long week already. Look at these lines.
I got more.
Yeah. How we doing, mate? You good?
Yeah, a little exhausted. 2 days in a row, I got up at 4 a.m. and did a Veeam user group meeting in New York. And yeah, so I'm going to be a bit slower than usual, folks. It won't be the normal jumpy Jeff.
You're going to come down a couple of levels, right?
Yeah, yeah.
Well, we've got people watching us anyway, Jeff. That's hi, Mum. Hi, Dad. But so I think based on last week or last month, we've been trying to do these every month. Me and Jeff saw that one of the topics that we think we should get into was around Kubernetes storage in general, and then also how that pertains to like data protection, data management, and all of that good stuff in there. So, as usual, we generally show a bit of theory around the world of Kubernetes storage, things like CSI, Container Storage Interface, and we'll do something around that. And then I know, Jeff, even though you're tired, mate, I'm sure you've got something to show if it's working.
I do. I actually got it to work, believe it or not.
Oh, good stuff. Cool. So I just want to. In fact, let's chat about a few areas of Kubernetes storage, because we've both been talking about Kubernetes and Kubernetes storage for a while, and the world has changed a lot since the days of stateless versus stateful workloads, which is still a bit of a myth buster that I know I have to dispel when I'm out in the field having customer conversations and user group sessions. Jeff, what's your take on where we are now from a Kubernetes storage point of view, but also where we've been? Like when you first started with Kubernetes, what was your lay of the land?
So, like networking, I think storage is probably the second or first most complicated aspect of Kubernetes, if there is a most complicated aspect. The reason being is that it's very different, and there are a lot of choices, and it's hard to know what choices are good and what choices are bad. In fact, it a lot of times depends on what kind of workloads you're using or doing. So how has it progressed? Well, I'll be honest with you, I don't think it has in the sense of simplicity. But of course, the reason is the whole point of Kubernetes is flexibility. And flexibility, you can't get flexibility with simplicity. I just don't think that's possible. People try to sell that as products, but generally, it's like you get a UI. A UI makes things easier, but then you lose command line free kind of abilities. So I don't think I don't want to say move forward, because it's really moving forward to simplify things. I think it's still the same amount of effort, not struggle, effort to learn it. And then you have to go and adjust and figure out what you need. And on-prem is very difficult, hence why a lot of people use cloud storage, because it's a lot of work.
So yeah, let's so on that, I've had a lot of discussions with so the last session, if you didn't see it, me and Jeff spoke about virtual machines on top of Kubernetes using KubeVirt or OpenShift virtualization, and obviously that needs a layer of storage. And I think a lot of the misconception there is that you're going to get the same storage experience that you get within VMware or within vSphere. You add a data store over NFS, iSCSI Fiber Channel, and you start storing your workloads on that. Kubernetes, yes, it's another platform. It's definitely not a next to get, especially if you're running storage on-prem. I think the flexibility, I think the biggest game changer in Kubernetes storage was the CSI, and the CSI is probably 5+ years, 6 years old, Jeff. I don't know if you know that, but it's relatively old. And the way I frame this in talks, like beginner talks, is it's the universal travel adapter for storage. So over here, you can only just see my hand. Like on one side, you've got all the different enterprise storage solutions that you have on-prem that might be being used for your virtualization, your VMware-based workloads as well today. Then over here, you've got Kubernetes and all the different distributions of Kubernetes that we've discussed and mentioned on previous shows. And what the universal adapter does, or the CSI, is it bridges that gap. So I can plug in any storage and I can get all of these features and functionality. Jeff's hair dryer, my hair straighteners, they'll work wherever we go in the world, and we're going to plug those 2 pins, 3 pins in and get power. And that's the same from a storage point of view within the CSI, is that the CSI exposes 5 things. I can't actually remember how many it is off the top of my head, but it'll be elements like volume cloning. It'll be things like thin provisioning, volume snapshot control, like classes, etc. It'll be there's some structure to that, and then from a storage point of view, they choose whether they plug into all or some or many or all of them, or all of that. So I think that's been my analogy of what the CSI is, and I think I've already said far too many. I just want to share the Kubernetes documentation.
What you're saying is true. What you're saying is true. It was a lot worse. I forgot to mention that. It used to be that everything was in tree, which meant, and networking too. So you had to wait for the Kubernetes new API to come out to add storage. So you're right. The CSI has made a huge improvement. Jeff, how could you have forgotten that?
Yeah, I did a session, what seems like a long time ago, where, sorry, I'm trying to get a password to enable me to do screen sharing on this machine. I did a session in Toronto, actually, Jeff. What session was that? What event was that? Cube Huddle? Cube Huddle.
I remember there. Yeah.
I basically I did a session called Fantastic Features and Where to Find Them, specifically around storage. And I've got some slide where, if we want to touch on what that universal plug socket looks like, if my computer will ever let me share anything. Here we go. And then why didn't that work? That's a good start. So you might notice that I'm on a different machine today to my normal one because my camera stopped working. And as much as I don't believe anyone wants to see my face, I think it works for this sort of content. Why? Jeff, I don't know if you could pull up a browser.
Sure.
And just share. If you do a Google search for Kubernetes storage, the Kubernetes.io documentation is where I was going to go, and then we can get into the.
Okay, 1 second. I'm just going to find it. You get all the. There we go. Okay. Now I'll go back to the browser. I got to find you. I've got too many tabs open. That's a big no-no before you go on a thing. You don't, gosh, what am I going to share? I'll share this. I want to show the entire screen.
Yeah, sorry.
I don't want to share the wrong thing. Oh, there we go. We'll share that, and then I'll just go to this. You can see us now. So there we go. Kubernetes storage. Can you see that?
To the scene. Yeah. So this is what I want to talk about. Like in regards to, and I've said this before about Kubernetes, in that it's just another platform, but everyone in the Kubernetes community loves to call things different things. So when we think about volumes, persistent volumes, projected volumes, ephemeral volumes, like let's not take all of these into account. What we like, they obviously all have a place, and they'll have a use case for what you want to achieve within Kubernetes. If you want to run Postgres inside your Kubernetes cluster, then you're going to need to know how I keep persistence within that database. In that session that I did, I actually created a Postgres container with no storage, so it's ephemeral. So we can write all the data you want to that until that pod then gets destroyed, and then suddenly all of our data's gone. So we have to really think about when we start putting stateful workloads, and stateful workloads might be a database, but it also might be some sort of log or configuration that we need to keep there. So ephemeral could be just I don't need it. And if any of you have used public cloud, specifically Microsoft Azure, there's always an ephemeral storage disk on your Windows servers for like temp files, for temp downloads, or like, and every time you bounce that machine, it goes away. So don't store anything important there. And that's kind of an ephemeral volume. Now, you can use them in Kubernetes. Then it might be another case is that maybe I've got my gold, silver, bronze type storage, and I've got some really fast disk, I've got some medium tier disk, and I've got some really slow spinning disks. That's where storage classes come in, and we start to label them gold, silver, bronze, or whatever you want them to do, and they might have different variabilities on that. So you have storage classes. Then we have the persistent volume claim, which is what we're going to deliver to the application. And then the persistent volume is where we're actually going to store the data. All very different terminology to, if you're a vSphere admin, you probably have never heard of any of this terminology, but still it's storage underneath being presented via a protocol. So I kind of wanted to touch on that. If Jeff, if you do another browser search, another Google search for Kubernetes CSI, because I don't think it's in there.
Yeah, I can't remember. That's a good question, because I can't remember if it. Oh, there it is.
Yeah, that top one. And this is that universal plug socket that I was talking about. So prior to the container storage interface, so you're looking back at version 1.13, so years ago, before I even could spell Kubernetes. And this is that universal adapter to be able to plug in your enterprise storage or cloud-based storage into your Kubernetes environment, your Kubernetes distribution. So any Kubernetes distribution is going to have this CSI plug, and you plug in your storage, whatever that may be. And I know Jeff's got some storage to show off that kind of relate to what we were talking about from a home lab perspective, because I assume Jeff's not running some sort of NetApp or Pure Storage that.
No, my home lab wouldn't be able to take it. And one thing I wanted to also, just an old story. I remember we had 2 Veeam people come to our service provider in Toronto in 2019, and this was before Veeam and Kasten started working together, and Veeam purchased Kasten. And I started getting Kubernetes. I said, what about backing them up? And the answer was, well, no, the containers, they don't have any storage, right? How that has changed, and I'll never forget that, because I looked in and said, well, yeah, Ephemeral, but it looks like they've got this, whatever. It's just because people didn't know at that point. So that is huge, because obviously, I don't know what you would run with. I guess you could run some kind of static websites on Ephemeral. I can't even pronounce it. That's how often I use it. So CSI is hugely important. It does snapshotting, which of course is hugely important for backup. And it's, the plug and play for storage, so that, companies can create their own drivers and just plug them into this, as opposed to putting them in tree. So what are my favorite types? Well, first of all, that's changed over time. My first favorite type was the Minikube CSI host path, which is, it's like a wannabe, because it's CSI, but it's on the local disk, but it does snapshotting. So this is how you could get, Kasten involved in all this. And that was my favorite at first. Now, I went to Ceph for a while. Ceph was very complicated. Well, for me, it was very complicated, but it certainly had a lot of powerful things about it. And I think if you're doing something large, that's really good. But I found something which I kind of find is in the middle, although I think it can be for huge production as well, and that's Longhorn. And anything with a kind of farmy name in it is going to be K3S, right? Rancher, the whole thing. So I've got some Longhorn to show you. And what I like about it is I can use I have 2 favorites. So Talos is becoming my favorite when it comes to distribution for completely, immutable, but for being able to get something done quickly and mess around, K3S. And so Longhorn fits in K3S beautifully. It's the same, they're kind of the same, made from the same parents, from the same developers, put it that way. And they give you this nice little, very intuitive dashboard, right? So this is just a single VM. In fact, I could find the command line somewhere in my billions of things, but no need. I can see it here. Single VM. So there it is, a K3S01, I call it. Very small, but look at this. Isn't this cool? And you got your little volume degraded. Now it says degraded because I forgot to do one thing. By default, it tries to have, I think, I don't want to lie in my tired mind, but like 3 replicas. Well, if you've only got 1 host, guess what? You're not getting 3 replicas, unless I guess you add 3 drives. But I didn't do that, so it's degraded, but that's a phony degradation. That makes sense. But yeah, so you get this nice little at-a-glance storage. If you want to add things, it's very simple. You got to go over to here. And now on smaller screens, that will be outside of the screen, I found. And believe me, I spent half a day trying to figure out how to add something, not realizing it wasn't fitting in the browser I had in the screen because it was over here. So that's one of those things you don't really tell people to not look stupid.
Jeff, just so for those that haven't like followed or seen any other of these videos, like, so your Kubernetes cluster is virtual in this instance?
Yes, it's a virtual machine. So this is an Ubuntu. Sorry, I missed the major facts. That's what happens when you get up at 4 a.m. twice.
You're good. You're good. That's why I'm
airplanes. So this is a Ubuntu VM, a single Ubuntu VM with a single node K3s distribution Kubernetes installed on it.
And then the disk layout to that virtual machine, is that?
Basically, it's just one single disk. It's one disk.
Okay, so that's an important factor that we should raise here as well. I know we're probably not going to get into too much of Ceph. It's been around for a long time, Ceph as a storage, but a fundamental difference of Longhorn and Rook Ceph is, I keep wanting to say Harvester, another SUSE project, and I'm lacking sleep as well. But Longhorn can take any partition of that disk. So your Ubuntu box has, I don't know how big the disk is, 100 gig. Do I see there 150 gig?
150, I think, yeah.
And that has the operating system on,
everything.
and then it's and then some of that partition is partitioned for Longhorn. Whereas if
I got even lazier. So I went full lazy mode on this. It's just taken. It's in var lib. I don't know, var lib ranch or something.
It's just a mount point within the Linux operating system. Yeah. So whereas with Ceph, you're going to have to give them a whole disk.
Raw too.
Yeah, exactly. So if you're creating a Kubernetes cluster on your VMware or your virtualization environment, you will have to give that an operating system disk, which is going to stand alone just for operating system. And then you're going to carve up multiple disks for your Rook Ceph environment as well. I'm using Rook Ceph on my Talus cluster because Longhorn, although it is an option, it would need to use a different disk. I don't know. Talus are doing some cool stuff around being able to partition disks and use disks as raw devices, though. So I might be talking out of school there. Cool. Sorry, Jeff, I butted in. You were
no. It's perfect. Like I said, I had like 10 cups of coffee, and there's a diminishing returns point where you have that. Kind of reminds me of going to the pub in college. You have that extra coffee, and you think it'll boost you, and you suddenly realize the more coffee you have, you get sleepier. I don't know how that works, and shakier too. But so Ceph, yes, you have to have raw drives, and that was. I mean, it's not difficult. You just don't format the file system. Here, though, I don't believe. I don't want to lie. I definitely formatted this XFS first, and then added it. I think you have to do that. The other thing I'm going to add here is that, and this is important for people who read some of the Veeam documentation and Kasten documentation, get confused about being able to back up to Veeam repositories, Kubernetes workloads. So you can only do that if your storage class is using what's called block mode in Kubernetes. I won't go too deep because we'll all fall asleep close to that anyways. But keep in mind, for instance, in Harvester, which is using Longhorn, it's experimental. And that is a different animal. So with a normal Kubernetes workload here on just normal Longhorn, I cannot back that up to a Veeam repository. It has to use the Copia format for Kasten. But I'd mention that.
Yeah, no, all good. So we've got the layer of storage within your Kubernetes cluster. We've got, I assume, some sort of storage class that this is into, giving you I assume you've only got one storage class unless you've got the CSI host path as well.
No, I said one. And I don't think I've even got, it comes with local path, which is kind of a K3s version, which doesn't have snapshotting either. So that's a real minor, I don't want to say minor leak, it's just you can't snapshot, so you can't do backups.
Yeah, so that actually that's a good point, and that goes back to that universal travel adapter. Is that okay? The power's the same wherever we go in the world. In theory, we plug it in and we get it inverted, and it works. I'm not going to get into a electronics course, but with the CSI, it's one of those pick and choose like what you've built, and that volume snapshot class. One of the capabilities, like if it's not there, then you can't do or leverage that capability. So like Jeff said, the CSI host path driver, which actually like most of us will play with that first and foremost in your journeys with K3S, with Minikube, with whatever, because it's just available. It's at there, generally out of the box. The CSI host path driver does have a volume snapshot class, but you have to add that in after. I don't know if you've done that, Jeff, but
yes, I had to. So that's a very good point. You have to install the external snapshotter for this to be able to snapshot. It's not, so that is not included in the default Kubernetes. So when you install Kubernetes distribution, like a K3S or vanilla, the CIS snapshotter is not there by default. Now, correct me if I'm wrong, I think OpenShift and some distributions like that actually install it automatically, and I think Harvester does too, but this K3S, I had to install it.
Makes sense. Okay, so you've got a storage class, you've got a volume snapshot class.
I can actually find it for you. 1 second.
I'm trying to visualize the building blocks before you can put, and you probably already have put by the looks of it. It looks like you're using some of this, Jeff.
Let me just, you know what? I'll show you because that'll make it easier. So let's get the storage class. Now I've created an alias. That's why I'm using K, normally a kubectl. K get SC. I'm lazy, so I'm not writing a storage class. And I might have local path. Oh, I do have local path. So I lied. I have local path. In fact, the reason I have that is before, I think with a local host CSI, there were issues with Kasten with the Prometheus pod. That might have gone away, but doesn't have it here. But I left it in anyways. So by default, and here's another problem which I haven't fixed yet. Do you see something strange here? Can you have two default things? No, that'll make things very defaultish, which, so I've got to remove that. But basically, by default, local path. I don't know why I've done that. I can remove that. But Longhorn is the storage class. Now, if I did not install the external snapshotter, I would get a not even no resources found. Doesn't exist in the cluster. This.
Yeah.
Get volume snap, and this one I haven't figured out the shortcut the short version. If you can tell me, I'd gladly use that class. Volume snapshot class. I probably misspelled it. Volume snap. I know I've got it because I'm casting on this. Snapshot. Something wrong with snap. Oh, there's a missing S. Snapshot. There we go. So there we go. And there's my Longhorn snapshot. That's what Kasten's going to leverage. I have to annotate my my Kasten namespace with that, and then it will use that. Now this thing's interesting too. Kate, have you seen this, Michael? The K10 clone snapshot class?
Yeah. So yeah, and that is, I don't think you'll see that with all. That is I believe that's the integration point into Longhorn, but I'll have to double check on what that actually is doing, because obviously if you look, it's created at the same time.
Yep.
As that. So
it wasn't an add-on, yeah.
So I was going to add, you mentioned annotation. Think of an annotation, and this is more general Kubernetes. You can annotate any of your objects, any of your Kubernetes resources. Think of it like a label. It's an instruction of saying this is what we'll use to do our volume snapshots within Kasten. But you should be labeling other resources within your Kubernetes cluster as well. I don't know if you've got any of that. It kind of goes outside. It's not just for Kubernetes storage, but annotation is very much labeling that
Yeah.
then can be used. Like you could use annotations to get certain aspects of an application.
Let me just show you what one looks like. Oh, annotations none. Well, that's oh, maybe it's the no. I'm Kasten. Yeah, I'm just too tired today to what was on this one? Maybe I redid this. I might have redone this.
You've got.
No, it's supposed to be on Kasten. It's supposed to be on Kasten. I didn't annotate it. That's interesting.
All good. All good.
Anyways.
So all the document, you don't have to worry about that because the documentation tells you to do that.
That's right.
So, okay, next then. So we've built the foundation. We obviously have the networking, we have the compute, and you've put the storage in play. After the fact, we've built this storage layer, which enables us to then create those storage classes. And then the next thing is around persistent volumes, persistent volume claims. And a persistent volume claim is something that is being asked of the storage. So that might be your Postgres. I don't know what Jeff has on his cluster that is potentially using a PVC.
Let's just see. I think this is what I normally do. I create this little fella. There we go. This is from the standard documentation, Kubernetes documentation.
Perfect. So it's just it's a 1 gig disk claim that is being asked for by something in Jeff's cluster. And the claim is at the global. So if Jeff just did kget PVC, that would come up with
nothing. Because I'm not using anything in the default namespace.
It's PV, persistent volume would come.
Oh, I'm sorry. You said yeah, there we go.
Sorry,
got a whole bunch of them. Yeah.
So when you deploy Kasten, there is some stateful elements to Kasten as well. So things like the catalog, things like login, metering, etc. jobs, they all get stored into these locations. And a PV is at the global layer, and then the PVC is something that's requested at a particular namespace layer. So as Jeff did, his namespace Nginx has a PVC that is using that particular persistent volume claim.
Yeah.
And what's being stored in that?
I think
demo,
just the Nginx, nothing. It's my little test thing.
Right.
But you can see like the Kasten ones, which are I believe are probably using local path, because I don't think, well, let's take a look. Get PVC and Kasten. No, Longhorn. Okay. So Longhorn won the battle of defaults because I had 2 defaults in there.
Huh. Yeah, I remember you mentioned something about Prometheus. I do remember a reason why it had to go onto local versus something else, but that was more in these roll your own home lab type environments versus.
Yeah. You wouldn't use the CSI host path for production unless you enjoy a roller coaster ride.
Yeah, because and that's a good point, because so let's say that Jeff's system, like Ubuntu box here running K3S, was a physical machine, and there was 4 others, 3 of them were control planes, and you were using the container, the CSI host. That means we're using a disk on each one. If that host dies, then all of your data on that particular persistent volume will be down for that at the same time as that. It's not a clustered storage system like what we have with Longhorn, like what you have with Ceph, where you have copies of that data spread across those disks or partitions that are making up that storage layer.
Yeah, exactly. Yeah. So it can get complicated, but at the end of the day, I would suggest if you become an expert in one, that's probably the best thing. Like, because there's others like OpenEBS I like a lot too, which is another really cool one. But what I found was when I was dipping my toe into all different ones, I was an expert in none of them, and so they periodically all blow up. So now I'm trying to focus on Longhorn.
Yeah. So I just want to go back to your example, Jeff, and kind of elaborate on what that looks like. So Jeff's using Nginx. and it's just if you go through the Kubernetes, like the link, we can share the links in the description as well.
Yep.
But if you search for Kubernetes storage, like you're going to get the examples that Jeff basically has gone through to get that persistent volume.
Yeah.
And
this isn't, I want to add here, Michael, this is really important because I remember the exams, you're allowed to see the documentation of the exams. So one of the things you do is you memorize where everything is. You can get there quickly and like copy a whatchamacallit manifest. Like, oh geez, I need, well, not that one, not PV recycler. I don't want to go there. But for a simple one like that, there we go, foo PVC. So just keep that in mind. You want to memorize where this is. Hence how I found it so quickly.
I'm just seeing what would happen if you did deploy that.
The recycle thing? I haven't seen that before.
No. The other PVC that persistent volume. Sorry, there. It doesn't matter. So, but if we think about how would you evolve that? So I've used Postgres as an example, but Postgres runs or is capable of running in a pod, and that Postgres container or pod will need some sort of persistent volume to be able to store that database in. It doesn't change. That Postgres that we know on a virtual machine in Linux or Windows or in the cloud is still Postgres. It still requires some sort of operating system, whether you're managing it or not, like cloud-based RDS or something like that. It still requires that compute. It still requires a database and somewhere to store that database. Shocker. So what I'm getting at is that persistent volume is where we're going to be. Sorry, persistent volume claim is where we're going to be storing that database file where we store all of our important records, etc., inside of that database, whatever that may be. And you can then elaborate on that. Being it's the same for Mongo, it's the same for Microsoft SQL Server that we see within containerization as well. Like it's not a million miles from what you already know, in that when you, like, example, you deploy a Linux box, an Ubuntu box virtual machine in vSphere. You've got a C drive, or you've got a root partition, which is where all of your operating system lives. Generally speaking, you're going to give that another disk, probably a more performant disk, and that's where your database files will reside. That's the same premise when it comes to Kubernetes as well. Obviously, in Kubernetes, we don't have a full-blown Ubuntu server. We only take what we need and containerize that to run Postgres. But then that persistent volume claim is just that other element, that other partition or that other disk that we're going to store the database files on. Hopefully that makes sense, Jeff, if there's anything to add. But yeah, hopefully that makes sense.
Yeah, I mean, just think of it as your storage, but it's different from other storage you've dealt with before, I guess is the easy way to put it.
Yeah, and another shout out to, like, this documentation. I've always found this documentation is a great place to play. There'll be there's examples all the way through this storage section, but equally over the whole, and I've mentioned this on previous chats that we've done, is that there is little scenarios that you can run through and start building out, like the Nginx that Jeff's put in. That's a great little demo to go and deploy your own little web app with some persistent storage, and then you can change that. And then if you kill the pod, it's going to come back up because the www folder is on that shared storage. I think that is the demo that they go through, Jeff. What else did we want to cover? Is there anything else you wanted to add, Jeff? I know we're running on fumes, but
yeah, no, my persistent volume claim is going down. No, I mean, that's basically it. The documentation is great, and you got to follow it because there are constantly things that are changing. Like, I haven't been back here in a while. Like, there's Windows storage there. I don't know if that was there before. I'm just take a look at Windows storage, persistent volume. Yeah, I'll have to look into that. But I think the important thing I wanted to stress was you got to pick one, hopefully. And keep in mind, they're cloud ones too. So for instance, if I remember correctly, it was either AWS or Azure. There was a whole bunch. They had a whole bunch of different kind of storage classes. And which one should I choose? Of course, probably you want to choose the cheapest if you don't want to like go out of budget. But it's something you have to learn, and you definitely don't want to wing it. Guess the best I can say.
Especially if you are rolling your own Kubernetes on-prem, in virtual, on bare metal. Now, Kubernetes storage is a little bit less complicated when you get into the public cloud because a lot of it's done for you, but it's not all done for you either. Things like the snapshotter, things like there's elements that aren't in all public cloud offerings, although I think they've streamlined a lot more. I remember, I'll use AWS as the example. So when CSI was becoming the de facto, and Azure and AWS all was rolling them out, they had very different, like the defaults were very different. Some you would need the snapshotter installed, some you would need to do the whole CSI, some were like private betas that you'd have to like almost use Azure CLI to get yourself into. But generally speaking, you don't have to think too much about that. I think the other thing that I found with public cloud Kubernetes distributions is that it massively depends on the node sizes that you've chosen will determine the IOPS and the performance of the disk that you have within your shared solution. I don't know if that's still a thing. The reason why I know that is that we created an open source project called Kubester, which is a benchmark tool to hit your Kubernetes storage. So if you know what the IO pattern of your application looks like or your database looks like, you can do that against your Kubernetes storage, and it will give you some output to that. And yeah, we can go through that. I don't actually know what the latest is on Kubester, but I did quite a lot of shouting about it a few years ago.
Yeah, it was a great tool because it would help you determine whether, if I remember correctly, to whether your storage was ready for it. And didn't they incorporate that a bit into their into those scripts they have when you check for prerequisites Kubernetes or for Kasten?
Yeah, so Kubester, there's a couple of things. The bit that's interesting for me was the FIO. So if any of you have been storage admins, you might be familiar with FIO. FIO is a renowned tool. It must be 20 years old, and it's there for testing IOPS on your storage. Basically, it's been containerized. Kubester took advantage of that, put some automation around it, and now you can run that against your Kubernetes cluster. But yeah, to your point, Jeff, there was a capability of being able to run it against your CSI and make sure that your CSI was configured correctly. In fact, maybe that could be the last little thing that we run. I don't know where it is. This is a bit impromptu, and I know you're tired, so that might be.
You mean the Kasten?
Yeah, the curl command, and run it against your cluster.
I can get it. 1 second.
Which
never
is
here.
Yeah, while you're getting that, this is an element of what that Kubester is.
Documentation.
If you go docs.kasten.io.
Yeah, that took me 1 second. There, this is always the way I find it. I was gonna say easier. Latest. There we go. And it's in installing, and I guess it's in prerequisites. I bet you, or is it? Yeah, it's in here somewhere. Oh, primer, right?
Yeah, that's the one.
All right, let's run it, see what happens.
Yeah, this is.
But one thing that annoys me seriously is that you do a copy and paste, and if you're a newbie, you go, well, I wonder what's wrong with it. Well, it's because the dollar sign, the shell sign, is included in that, which is quite annoying. But
so you see here actually, so it's checking your whole Kubernetes cluster. So it's checking that you've got the tools available on your system. Well done, Jeff. That's all green.
Thank you.
And then it's checking the CSI. So it knows, right, we're using driver.longhorn is a CSI provider, gives you a thumbs up. Storage classes, you have Longhorn. Is it a valid storage class? Yes. Then we also have another storage class called Longhorn Static. Is it valid? Yes. Notice how it missed out the host path because it's not.
Yeah.
And then it says about your volume snapshot classes. Obviously, we have that. Great. And then it validates for generic volume snapshots. So before we had the CSI volume snapshots, we would use something called generic volume snapshot to be able to lift and shift data from A to B. So if your storage doesn't have that extra plug into the volume snapshot class, that would be a feature request right now to that storage vendor, knowing that 99% of storage vendors that I know that are working with Kubernetes, they've implemented that already. But there is a way and still that you could protect that. So this was basically a checker. It was a checker that was then implemented into Kubester. They would have borrowed bits from each other, but Kubester is a Golang binary that you run against your Kubernetes cluster. And there's a few things actually. One's this check. I can't remember what the flags are off the top of my head, but
yeah.
The other was the performance. And then I remember the last big feature that was implemented was a browse feature. So being able to browse into your PVC, clone that PVC and go and look inside it. Now, if that's a database, you can't really do much with that, right? Like it's a flat file, you can't do much. But if it's unstructured data, then you can.
You might have been seeing me typing here. This is what happens. You get exhausted. Why you should never work more like 24/7 because you're. So it took me a while to remember volume snapshot class, Jeff. 1, to remember the word. 2, to type it. That was big. But I did find the annotation finally because that's where it is. So you put the annotation here. And how did I figure that out? Not because my brain turned itself on, because when you're doing this, one of the things it checks in this script is whether or not you have annotated your snapshot class to say is true for snapshotting, right? And so if you do a describe Longhorn snapshot, which is a volume snapshot class, VSC, there's a short form. It actually says that annotations, and there it is right in front of you. So sorry that took me a long time. I would have failed the exam because I ran out of time.
I'm glad so we've gone full circle there. Jeff's woken up. He realized how to do it.
Yeah.
But that is important. Like, so you can annotate various stages as well, right? So you could annotate. Annotations is a whole different thing. Actually, I don't want to open that can.
No.
Right
That's a whole show. We don't want to do 2 shows today. I don't think we're in top form for that.
No, and I'm conscious of the time as well, Jeff. Is there anything else you wanted to touch on?
That's the main thing. I mean, it's a very deep topic. It's one of those things where you can have multiple sections of course about it. But I think we've given a kind of general overview. In short, read the documentation. Yeah,
but equally get hands-on and go through that documentation and get hands-on to it, because then you'll start to realize, oh, this is just like this in vSphere, or this is just like this in whatever you've worked with. And I think, like, whether it's if you've worked with terminology like LUNs and volumes, then things will start to fall into place, I think, is my advice. If you just stand back and you go, geez, I don't know what Jeff and Michael just said for 45 minutes on
I don't think we remember what we said.
Loads of jargon. But yeah, once you get into it, I think it's worth it's relatively relatively straightforward. I think.
Yeah.
Cool. Jeff, amazing. Thank you for turning up, even though you've been up such a long time. I think we're gonna have a think what we do in October. I think maybe there's a session that we do where me and Jeff bring some tools that we want to just show around, like, what do you use? And we can get into all the weird and wonderful stuff that we play around with. And then I'd like actually to get into other areas, like things like infrastructure as code and Terraform and Ansible, and dust off those bits, Jeff, into more of the DevOps side of stuff.
Definitely. Sounds great.
Yeah, and if you're watching this after, you've got something that you'd want us to talk about, want to come on, then let us know. Drop a comment, and we'll try and incorporate it into the next session. Jeff, thanks very much. Go and get your head down.
I will.